Hello, this is Dr. Benjamin Norris from the Chemistry Department at Frostburg State University. Today we're going to talk about naming binary covalent compounds. Before we do that, we're going to review the nomenclature of ionic compounds, because knowing how to name ionic compounds will help us name covalent compounds. If you have the formula for an ionic compound, like AgCl, we can generate its name by first determining which ions make up this formula, and then we just name those ions. AgCl is made up of the silver cation and the chloride anion, and the name of this compound is silver chloride. When we name a covalent compound, we start much the same way. For a compound with the formula NO, we first start by writing down what the cation and anion would be if this was an ionic compound. We always treat the first element as the cation and the second element as the anion. And so this would be some kind of nitrogen oxide. Many binary compounds would for many binary compounds, this name would be fine. But for the nitrogen oxides and other combinations, there's sometimes more than one formula for any two pairs of elements. In this case, there are at least 8 nitrogen oxides, and I have written their formulas on this page. So we need a way to be able to accurately name each of these nitrogen oxides so we can tell them apart. We use prefixes in front of the elements in the name to help us clarify which nitrogen oxide or which covalent compound we are talking about. The compound NO would be called mononitrogen monoxide because there is one nitrogen and one oxygen in the formula. Mono means one. This compound is sometimes simplified to nitrogen monoxide because nitrogen commonly occurs in compounds where there's just one nitrogen in comparison to the number of oxygens. You will sometimes see mono left off of the element name if 1 is the most common number for that element. NO2 would be mononitrogen dioxide, or just nitrogen dioxide. N2O, dinitrogen monoxide. N2O3, dinitrogen trioxide, and so on. The prefixes that we are using are derived from Greek numerical prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca for the numbers 1 through 10. You will notice some of these prefixes have a shortened version in parentheses. We use this shortened version when the atom or anion we're talking about is oxygen. So instead of monooxide, we just have monoxide. Instead of pentaoxide, it's pentoxide. This shortening makes the name of the molecule easier to pronounce. If one of the atoms in the binary compound is a hydrogen, you have a binary hydride. And many compounds form just a single binary hydride. And so binary hydrides are often named like their ionic compounds. For example, beryllium, BeH2, this compound is called beryllium hydride. HF, hydrogen fluoride, HI, hydrogen iodide, and H2S, hydrogen sulfide, all follow this pattern. Some elements, however, can form multiple binary hydrides. Boron, carbon, nitrogen, and oxygen are all elements that can form multiple hydrides. So we need to be careful when naming these hydrides. We can't just say boron hydride, carbon hydride, nitrogen hydride, and so on. We need to be able to specify which compounds we're talking about. Some of these hydride compounds have commonly accepted names that are used by everybody. We are familiar with some of them, though some of them this might be the first time you've heard of them. BH3 is called borane, and B2H6 is called diborane. CH4 is methane, and C2H6 are ethane. You've probably heard of these compounds of carbon and hydrogen. NH3 is ammonia, which is probably familiar to you. N2H4 is hydrazine, which maybe you haven't heard of. H2O is water, and H2O2 is hydrogen peroxide. Notice that hydrogen peroxide is named like it's an ionic compound because it contains the O2 2- ion, or we name it like it contains the O2 2- peroxide anion. The hydrides of carbon are so numerous that we have developed an even more complicated nomenclature system that you will learn about in organic chemistry. This nomenclature system is focused on the structure of the molecules, in other words, the way the atoms connect together, and not just the composition of the molecules. The hydrides of carbon exhibit isomerism, which means the same formula can account for more than one different structure, and the nomenclature system needs to account for that. If you continue your study of chemistry into organic chemistry, you will eventually learn how to name all of the hydrides of carbon and other organic compounds. Here are some common hydrides of carbon, and you may recognize the names of these molecules from different places in your daily life.